In this session, we want to look at implementing a constructor from our UML model in PowerShell. So here is my stuff class that we've been working with. It has the three properties, a number and a string and a Boolean. And it has a stuff constructor specified as long as a double stuff method. And then we find here is the activity for the constructor, stuff, member stuff. So remember the constructor name is conventionally the same as the class name in object-oriented mindsets. And so the first stuff here is the type, the name of the class stuff, and the second stuff is the method, the member that happens to be a method that happens to be the constructor in here. And so we're saying that whenever a stuff object is newed up, that this constructor method should run, and that should initialize the property values. That's the purpose of a constructor, is to guarantee that these properties will be initialized to certain values. So far, I haven't set them to anything. So in our stuff constructor, then, property A should be set to the value of false, property B should be set to a literal string initial value, and property C should be set to a literal numeric value of 42. Okay, so let's look at the code here then. I'll zoom in a little bit and say that here's our class name stuff with our properties declared here. Again, no initial values assigned to them. Some languages will allow you to set values there, some won't. But either way, we have the constructor method here now, and between the curly braces is the definition of that, which I've now added three statements to assign the values to property A, B, and C. One new thing we see here is the keyword this. And so this is a keyword in most object-oriented languages. Yeah, some will call it self. Either way, the purpose of this is when the machine is running, okay, there's always a notion of a current object, the one that's in focus, the one that's being acted upon at a time, at any given instant. So yes, the machine operates very, very quickly, but it can only be doing one thing at a time. Now, I know that we have multi-threading, which we'll deal with later, and we have multiple cores on modern CPUs, so we do have some degree of parallelism there and concurrency, but I'm going to say that for any given core or thread, it can only be doing one thing at a time. It can only be acting upon one object at a time. So, for example, when we new up thing 1 down here, thing 1 will be the object in focus, and so the machine will keep track of the variable this. Okay, that keyword this is a variable that will represent the current object. So when thing 1 is being newed up, this will have a value of thing 1. But when we come down here in the next statement and new up thing 2, this will take on the value of thing 2. And so another way to look at that then is we're creating a class, a classification, a category of things called stuff things. They're types of stuff. And so each one of them can have their own property values because they each have their own chunk of memory. So how do we know which one is going to be assigned which? And the answer is by this keyword this, which will always tell us which one is in focus, if you will, at the moment. So again, when thing 1 is being newed up, these values are going to be set. Now, the constructor is the same for all of them, so thing 1 will be initialized the same as thing 2, and so on, until we add some parameters later. Okay. But property A is being assigned the value of false. In PowerShell, that's $false, the built-in variable that has the value of the notion of false. Property B is being assigned the literal string initial value, and property C is being assigned a value of the literal number 42. Okay, great. And then the rest of this is pretty much the same. We're going to new up two objects, one with a PowerShell mindset and one with a .NET paradigm. So I guess let me grab this, copy this, and come over to my editor, paste it in here, and I will go ahead and save that. I'll bring up my command line interpreter and say, hey, PowerShell, why don't you take a look at that? and it runs. Great. Okay. You probably would have expected that, and just as I lull you into this false sense of security, I will break it in a moment. But that seemed to work, and then we know that we could come in here and we could say something like, okay, write host. Let's see, we want to take a look at thing one member. I'm going to say property B. Okay, and save that, and then tell PowerShell to take a look at it, and lo and behold, the value of thing one property B is an empty string of characters. And you're wondering why that is. And did anybody catch it? That is because I asked for the value, the member property B of something called thing, not thing one or thing two. And so what we see is PowerShell was fine to say, hey, you want a thing one, and that thing one happens to have a property B member? Sure, it made it up for us. Now, a lot of languages will not do that for you. But PowerShell says, hey, you want to create something and you want to give it a member, go ahead. So I'm going to change this to thing one, save that, and oh, there we go. Okay, we see the initial value, the literal string initial value there. Okay. And so you can go on, you could look at other things with that. I think for the moment what I want to do is to come over here and say, we haven't been giving any attention to the strongly typed versions. So let me select all of that, copy that, and come over to my editor. I'm going to Control A, select all, and Control V, paste that, and replace all of that with the strongly typed version. So Control S to save that, and then I come over and I say, okay, PowerShell, take a look at it. And there's an error. Why? What's going on here? Well, a few things to learn from this. New object, exception calling .ctor with 0 arguments, exception setting property B cannot convert initial value, initial value, in quotes, to type system member double. Error input string is not a correct format. And then it goes on. Okay, let's break this apart a little bit. Apparently it was having problems coming. The problem came from the new object call. It was trying to new it up and couldn't. We'll deal with exceptions, which, yeah, and we'll see that in UML. We'll see exceptions. Excuse me. Essentially, I usually say there's 3 types of errors that can occur. There are syntax errors, like if I type something wrong, like I did here. There are runtime errors, where all the code is translatable for the machine. The machine understands what you said, but it can't carry it out for some reason. The usual culprits for runtime errors are memory errors and I/O device, input-output devices that aren't available or can't take the output or whatever. And then there are logical errors, which are the hard ones to find because the machine has no idea anything was wrong. It was something in your design, in your logic, and you would have to know what was expected to happen and see that it didn't to know that that occurred. Okay, we do have another subcategory of runtime errors. And the problem with the runtime errors, if we were limited to memory errors and I/O errors, then those usually oftentimes cause a program to just crash. That's not very friendly. We'd like to be able to say, hey, is it possible to recover from not enough memory or some I/O device that isn't there or responding or something like that kind of. And better yet, could we detect other conditions at runtime that would cause an error, but be able to handle them gracefully? And those are what we call exceptions. So more on that later. But what happened, an exception was generated when it was trying to call the constructor at runtime, when this code was actually running. And in fact, .ctor is an abbreviation for constructor. You'll see that in a lot of languages, a lot of documentation. With 0 arguments, well, that's because when we were calling our constructor here, we didn't pass out any arguments. Our constructor doesn't expect any arguments. That's not really the problem, but we recognize that. Exception setting property B, and it says it can't convert the value of literal string initial value to a type system member double. Well, why is it even trying to do that? Well, if we look in our constructor, and actually in our class, we see that, oh, here's where we're trying to set property B to a literal string. But if we look in the declaration for the class, we strongly declared property B as being a double type of value, not a string. So what I'm going to do is I'm going to fix this by saying, oh, property B, I'm trying to set that to a string, so I'm going to make that my string type. And property C should be my numeric type, which I'm going to use a double. Okay. And we'll talk more about different types of numbers, but in UML, we generally don't have to worry about it. We're leaving it up to the implementer. But now we are the implementer, so we're going to have to figure out, should it be an integer or a floating point value, and if so, how many bytes of storage do we need, and all that other stuff. But anyhow, for the moment, I'm going to correct this by saying, oh, now I'm actually assigning the type that I said it should be. So now, if I come over here and run this again, oh, PowerShell is happy, and in fact, I can say write host $sign thing one member property B, and then I can save that, and I can tell PowerShell run that again and see that indeed I am seeing that it did work. That PowerShell did create this thing1 object. It did call the constructor and assigned property B the value of initial value, and then we could write it out. One last thing I'll point out here is that the purpose of those constructors, once we created thing1 here, this instruction, this statement does not finish until after the constructor finishes. So there's no way we can ever do something with a thing1 object that has not been initialized.